Hi students, welcome to the video lecture 1 on the topic fluid kinematics, which is taken from module 2. So in the today's class we will study what do you mean by fluid kinematics, what are the different types of fluid flows. So fluid kinematics is defined as that branch of science which deals with the motion of the particles, fluid particles, without considering the forces causing the motion. So in the fluid kinematics, we are not going to study we are going to study the motion of the particles without considering the forces causing the motion. So such type of study it is called as the fluid kinematics. So here we will study what are the different types of fluid flows. So the fluid flow it is classified as first one is steady and unsteady flows. Second one is uniform and non-uniform flows. Third one is laminar and turbulent flows. Fourth one compressible and incompressible flows. And fifth one that is rotational and irrotational flows. Now let us study one by one. So first we will study steady and unsteady flows. Steady flow is defined as that type of flow in which the fluid characteristics like velocity, pressure, density, etc. at a point do not change with time. This steady implies no change with time. So for these all these characteristics of the fluid, for example, this velocity dou v upon dou t is equals to 0. So these x naught, y naught, z naught, these indicates the directions of the fluid flow, coordinates in the x coordinate, y coordinate and z coordinate, whatever the coordinate may be. This v indicates velocity, this small t indicates time. So there is no change of velocity with respect to time. For that purpose, we have written this mathematically, this dou v upon dou t is equals to 0. Similarly, for pressure also, there is no change in pressure with respect to change in time. For that purpose, we have written here dou p upon dou t equal to 0. Even for density also, dou rho upon dou t equal to 0. That means steady flow implies no change with time. That means even after whenever there is a change in time, the fluid characteristics like this velocity, pressure, density, they does not changes with time. So now coming to the unsteady flow, it is exactly opposite to that. Is that type of flow in which these velocity, pressure, density, etc. at a point, these changes with respect to time. For that purpose, mathematically I will write this dou v upon dou t is not equals to 0. That means it indicates velocity is changing with respect to time. Even for pressure also, dou p upon dou t is not equals to 0. For density also, dou rho upon dou t is not equals to 0. That means the fluid characteristics, they are at a point it changes with respect to time. Next we will study what are uniform flows and non-uniform flows. So this uniform flow is defined as that type of flow in which the velocity at any given time it does not changes with respect to space. Here space means that is the length of the direction of the flow. Here in uniform flow we are not bothered about pressure, density like that way. Here uniform flow it is related only to the velocity. That means there should not be any change in velocity with respect to change in space. That means dou v upon dou s. This s indicates the direction of the flow. That means dou v upon dou s is equals to zero. That means there is no change in velocity with respect to change in space. For example, here just I have drawn a line here. This is one end point, this is another end point. If the fluid particle is moving from this end to this end, so whatever the velocity is there at a left end point, the same velocity should be there at this point also. Even when the fluid particle, when it moves through the distance, this much distance, or when it moves through a space, that means the velocity should not change. Here also the velocity should be same. Here also at this point also the fluid particles velocity should be same. So such flows are called as uniform flow. See here, dou v upon dou v, it indicates change of velocity. Dou s, it indicates the length of flow in the direction of s. So non-uniform flow, it is also exactly opposite to that. Non-uniform flow is that type of flow in which the velocity at any given time it changes with respect to space. So such flows are called as non-uniform flow. For that purpose, mathematically, how we will write this? Dou v upon dou s is not equals to 0. That means if the velocity of the fluid particle at this end is suppose 5 meters per second, and if I measure the velocity at this end, at this point, the velocity may be 6 meters per second, or the velocity may be 4 meters per second, whatever it may be. That means the velocity at any given time it changes with respect to space. So such flows are called as non-uniform flow. So next we will study what do you mean by laminar flow and what do you mean by turbulent flow. So laminar flow is defined as that type of flow in which the fluid particles move along well-defined paths or streamlines, and all the streamlines are straight and parallel. That means here the fluid particles, they are moving in a well-defined path. See, this is the fluid particle. This is the direction of the fluid flow. This is the direction of the fluid particle. This is also the direction of the fluid particle. So you can see here these fluid particles, when they are flowing in a large layer, they does not mix with each other layers. They are moving in a well-defined path. Here in this path only they are moving. These fluid particles are not mixing with each layers, and all these streamlines are straight as well as parallel. For example, flow of blood in the arteries and veins. So this is a very laminar flow. So very straight and parallel the blood will be moving in our arteries and veins blood. For example, groundwater flow, which is at a very low velocity. Said groundwater flow, if it is at a very low velocity, then we can consider it as a laminar flow. Otherwise it comes under the turbulent flow. So flow through the capillary tube, very slowly the liquid will be rising in the capillary tubes. So these all are considered as the laminar flow. So turbulent flow is defined as that type of flow in which the fluid particles move in a zigzag way. See, you can see here the fluid particles, how they are moving. Their order is non-existent. They are not moving in a straight and parallel. They are moving in a zigzag way. You can see here the fluid particles, and the layers of the fluid particles are mixing with each other, continuously hitting the walls of the container in which the pipe in which the fluid is flowing through a pipe. So it is moving in a non-orderly manner, or we can also define it as the highly disordered fluid motion that typically occurs at high velocities and is characterized by the velocity fluctuations. It is called as the turbulent flow. That means, for example, the discharge of smoke into the atmosphere. If you can see here, in the factories, the smoke will be discharging through the chimney. So you can observe that is the turbulent flow. Next, we'll study compressible flow and incompressible flows. So compressible flow is that type of flow in which the density of the fluid changes from point to point, or in other words, density is not constant for the fluid. That means rho is not constant here. So when the density of the fluid changes from point to point, then such flows are called as compressible flows. So incompressible flow, it is exactly opposite to that only here also. Is that type, incompressible flow is that type of flow in which the density is constant for the fluid flow. That means density does not changes during its fluid flow. So such types are called as incompressible flows. So usually the liquids are generally incompressible fluids. Even though the liquids are compressible, they are compressed to a very little extent, and which is negligible. Very little extent. Usually the liquids are considered as incompressible fluids only. Even though the compressibility is there very less amount, so it is negligible, while gases are compressible, so you can compress the gas up to some extent. So such flows are called as compressible flow. So mathematically for incompressible flow, this rho will be equals to constant. So last one is the rotational and the irrotational flows. So rotational flow is that type of flow in which the fluid particles, while flowing along streamlines, it also rotate about their own axis. So whenever the fluid particle is moving, so if it is rotating about its own axis, the fluid particle is moving also and it is also rotating about its own axis, then such type of fluid flows are called as rotational flows. And suppose if the fluid particle while flowing along streamlines, it does not rotate about its own axis, and such type of flow is called as the irrotational flow. Irrotational flow. So next we'll study what do you mean by discharge. So this discharge, it is defined as the quantity of the fluid flowing per second through a section of pipe or any channel. It is defined as the quantity of the fluid flowing per second through a section of pipe. That means how much fluid is flowing per second. That is nothing but the discharge. For an incompressible fluid, that is liquid, the rate of flow, this discharge is also expressed as rate of flow. Rate of flow is also same and discharge is also same. So the rate of flow is expressed as the volume of fluid flowing across the section per second. This is for liquids, and whereas for compressible fluids the discharge is expressed, that is the rate of flow is usually expressed as weight of fluid flowing across the section, and whereas this discharge it is denoted by the symbol Q. This discharge it is denoted by the symbol Q. See here, for liquids the units of discharge are meter cube per second, or it may also be expressed in liters per second, because for incompressible fluids discharge is expressed as the volume of fluid flowing across the section per second. So meter cube, meter cube, it is in volume only. Liter is also measured in volume only. For that purpose the liquids, the units of discharge are meter cube per second, or it may be in the liters per second. So for gases the units of discharge are kilogram force per second or newtons per second, because the compressible fluids the rate of flow, that is discharge, is usually expressed in terms of weight of the fluid flowing across the section. So this discharge Q is calculated by the formula A into V, where A indicates cross-sectional area of the pipe and whereas V indicates average velocity of the fluid across the section.